Now we're going to look at multiplying matrices. By the end of this, you should be able to identify if a pair of matrices can be multiplied together, and you should be able to find the product of those two matrices. So here's the trick to multiplying matrices. We need to know that the number of columns in the first matrix match up to the number of rows in the second matrix. And as long as they do, we can also determine how large our product will be. So we can only multiply if these two numbers are the same. And we know that their product will be a matrix of size m by p. It will have m rows and p columns. So this is how this is going to work. Here I've got what looks like a relatively ugly matrix, but it should help you figure out how this is going to work. First, we've got to check to see if we can multiply them. So let's call this matrix A, and this one matrix B. A has dimensions 2 by 3, 2 rows, 3 columns. Matrix B has dimensions 3 rows and 2 columns. So these match up. The number of number of columns in the first matrix matches up to the number of rows in the second matrix. And we know that our product should be a 2 by 2 matrix. So the way this works is we take all the elements in row 1. We're going to multiply each of them to the elements in each of the elements in row 2 and add those products together. So we take that R1A element and we multiply it to the C1A element. So it's this element matches up with this element. We then add that to the product of the second element in that first row and first column. So the second element in row 1 times the second element in column 1. And we add that to the last element in the row and column. So the last element in first column, last element in the first row, and the last element in that first column. There's my first term. Now, it looks really ugly because we're not actually multiplying numbers out, and you'll see in a minute that it'll get a little easier. But this is the basic setup. So now, if we wanted to go for the element underneath that, we're going to take that second row and the first column. So multiply the second row first element by that first element, and keep going through that process. So second element by second element, and third element by third element. So up here, this is the product of row 1 and column 1. Here we have row 2 and column 1. So next we're going to look at row 1, column 2, and then finally row 2, column 2. So if I write this out quickly, we take the first element of row 1, multiply it to the first element in in column 2, and we just keep going. And as you can see here, so we've got row 1, column 1, row 2, column 2, row 1, column 2, and row 2, column 2. If we throw numbers into this, it's going to make life a lot easier. So how about we look at the next problem? The setup's similar to this previous problem. So what we're going to do here is first check our matrices again. I'm going to call the first one A and the second one B, just for simplicity's sake. A has 2 rows and 3 columns. B has 3 rows and 2 columns. These match up, which is what we want. And our product will again be a 2 by 2 matrix. So what we're going to do is figure this out. I'm going to take the first element and the first element, so it's 3 times -1. We're going to add that to the second element and second element, 1 times 2, and we're going to add that to the third by third, 0 times 5. I'm then going to drop down, -1 times -1, plus 4 times 2, plus 2 times 5. So that's my first column done. Second column, I'm going to go through the same process. 3 times 0. This time I'm using the second column instead of the first column. So 3 times 0 plus 1 times 3 plus 0 times 0. Just matching up the elements from rows to columns. So here again, first row, first column, multiplying these by these and adding the products together. Second row, first column, that's what's down here. First row, second column, that's what I have here. And finally, second row, second column, -1 times 0 plus 4 times 3 plus 2 times 0. I like setting my problems up this way because that way I can see the first row is what look like the coefficients of each term, and the first column is inside the parentheses each time, and the same down here. You've got your columns and your parentheses and your rows on the outside. So then all it's just a matter of is some simple adding and multiplying. 3 times -1 is -3, plus 2 plus 0, -3 plus 2 is -1. 3 times 0 is 0, 1 times 3 is 3, plus another 0 is 3. 1 plus 8 plus 10 is 19, and 0 plus 12 plus 0 is 12, and that is your product. So your product is -1, 3, 19, and 12. So again, let's check to see if we can multiply here. Again, there's A, there's B. A is 2 by 2. B is 3 by 2. Well, my rows and columns don't match up, so we can't multiply these. Since the 2 and 3 aren't the same number, we can't multiply. Finally, last one. Again, I'm going to call my first one A and my second one B, just to make life easier on myself. A and B. A is 3 by 1. B is 1 by 3. So I've checked, and I should be able to multiply these together. My answer, or my product, should be a 3 by 3 matrix. So here we go. First row times the first column is -2 times 1. Underneath that, second row times the first column is -3 times 1. Third row times first column is 1 times 1. First row times second column, -2 times 2. Second row times second column, -3 times 2. And then third row, third column, 1 times 2. And finally, first row times the third column, second row times the third column, and third row times the third column. Multiply each of these out and you'll get your answer. -2, -4, -6, -3, -6, -9, 1, 2, and 3. And that is your product matrix. So take the first row by the first column, second row by the first column, third row by the first column, however you want to organize it. But you need to make sure that you get all the terms in there. And the great way to check if you got the right answer by checking your products is using this matrix up here.